Hey guys, today I want to talk about understanding double angle formulas. We're just continuing to develop our trig identities. So we're just going to go ahead and develop some new formulas that we have. And I'm sorry that just a lot of formulas that we got to kind of memorize. But we know our sum formulas, right? So let's say we have two angles that are the same, right? U plus U, right? 30 degrees plus 30 degrees or whatever the case may be. So we'll use our summation formulas here. So sine of u times cosine of u is plus, and then you switch it, right? Cosine of u times sine of u. But because it's the same angle, then essentially what you're left with is 2 times sine of u cosine of u. And this is what we call the double angle formula for sine. Okay, so this is one of them right here. All right. So sine of u, 2u, sine of the double angle of u is equal to 2 times sine of u cosine of u. The way I try to remember it is, you see this 2, it just kind of comes out to the front, and then sine times cosine, or half of this angle is what's left in here. But you got to remember this formula. What about cosine? Well, if you make the double angle here, well, that becomes cosine of u times cosine of u plus, well, it becomes a minus, and then we use sine of u times sine of u. Well, cosine of u times cosine of u becomes cosine squared. Sine times sine becomes sine squared. And this is another trig identity that you have from cosine of the double angle. So that's the first one you got to memorize, okay? Cosine squared minus sine squared. Well, if you remember our Pythagorean identity, sine squared plus cosine squared equals equal to 1, I can rearrange this guy, okay? I can rearrange it. Cosine squared is equal to 1 minus sine squared. I can put this guy here, this guy, put him in here, and then I have this relationship. If I do the math, I get 1 minus 2 sine squared of u. And that becomes the second identity for the cosine double angle. And then we do the same thing with sine, okay? Sine squared, I bring this guy across, becomes 1 minus cosine squared of u. So this guy gets plugged in right here. So that becomes cosine squared of u minus, okay, and then instead of cosine squared, you're going to put 1 minus cosine squared of u. Distribute that negative, and then you end up with cosine plus cosine, which gives you 2 cosine squared of u minus 1. So that's a third one, okay? And so you have 1, 2, 3, 4, and I'm sorry to give you another one. But this one, I didn't do the proof. I just kind of give it to you just for sake of time. And its tangent of the double angle is equal to 2 tangent of u over 1 minus tangent squared of u. And if you notice, the 2 gets kind of jumps out to the front. You're left with the tangent u, and then 1 minus tangent squared of u. Okay, guys, so basically it comes down just to kind of memorizing it. But let's just go through some examples here, see how we can apply it, okay? All right. So we have this triangle, and we have to find the different double angles here, okay? So we have to memorize it. So sine of 2 theta is going to give me 2 times sine of theta and cosine of theta. There it is, just using the formula. So I got to find what's sine of theta. Sine of theta is opposite over hypotenuse. Wait a minute, I don't have the hypotenuse. Well, you're going to have to use a Pythagorean theorem, okay? So, and you guys know how to do that. So it would be 3 squared plus 4 squared is equal to c squared, and you end up with c is equal to 5, okay? That's 9 plus 16, so that gives you 5. So you're gonna have to fill in the triangle in order to figure it out. So sine of theta is gonna give you, okay, what is sine? Opposite over hypotenuse is gonna give you 3/5, and then cosine of theta is gonna give you 4/5. So you just multiply that out. That's 12 times 2. That's 24 over 25. All right, and that's it. What about secant of 2 theta? Well, secant of 2 theta, remember, I don't have secant, but I do know that it's a reciprocal trig ratio of cosine. So what I'm going to do is I'm going to first figure out cosine of 2 theta. Well, Sandoval, which one do I use? Well, you can use any of the 3. Okay, and for us, we'll go ahead and just use this one, 2 cosine squared. Okay, so this is gonna give me 2 cosine squared of theta. Take away 1. So how do you do that one? Well, you got 2. Well, what's cosine squared of theta? Well, what you're gonna do is you're gonna find cosine of theta, and then you're gonna square it. And we already found cosine of theta, right? It's adjacent over hypotenuse. So this is 4/5. And that's going to be squared. And then we have the minus 1 over here. And then we just do our math, and that's going to give us 16 over 25. Take away 1. And what is that? 32 over 25 minus the 1 becomes 25 over 25. And that's going to give us 7 over 25. Not bad. Okay, so you see how we did that? So I'm basically using my double angle identities to simplify this out. Okay, don't just go ahead and plug it in. But what did we forget? We found cosine, right? What do we got to figure out? Secant. So now the last thing I got to do, because right now I figured out cosine, I have to do the reciprocal. So actually this guy ends up becoming 25 over 7. And I'll just leave it like that. I think your professor would be okay with that. What about tangent of 2 theta? Now, you're just going to have to memorize it. Remember, it becomes 2 times tangent of theta over 1 minus tangent squared of theta. Okay, well, what's tangent? We got a triangle. Tangent is opposite over adjacent. So let's do that here. Opposite. What's the opposite? Opposite is 3. Adjacent is 4. So it's 3 over 4. Okay. And on the bottom you get 1 minus, same thing, 3 over 4. But we're going to have to square that. And remember, this becomes 6 over 4. And then on the bottom, you're going to get 1 minus 9 over 16. All right. And we're just going to have to do the math. So let's go ahead. 6 over 4 reduces into 3 halves. 1 becomes 16 sixteenths minus 9 sixteenths. And that becomes 3 halves. On the top, on the bottom, we get 7 sixteenths. And boy, I ran out of room. So we're going to have to go ahead and, let's see here. 3 halves times the reciprocal of 7/16, which would be 16 over 7. Remember, when you're dividing, it's the same thing as multiplying by the reciprocal. So this ends up being divided by 2 is 1, divided by 2 is 8. So we end up with 24 over 7. And there it is. And sorry, guys, should have given myself some more room. But that's how we do it. So you notice how I'm using the formula, you then using the triangle to plug it in, and then just using my math. Okay, let's see if we can do some equations, some expressions here. So remember, you're gonna have to keep in mind that you're using your identities. Okay, so 4 cosine of x plus sine of 2x. Now, how can you figure out, like, when do I use it? When? How can I figure out what to do? Well, you see here, you have that 2x in the middle. Inside, so right away it kind of gives you an idea. You're gonna have to use your double angle formula. So we're gonna have 4 times cosine of x plus, remember, the 2 comes out to the front, sine, and then you take half of this guy. Half of 2x is just 1x, and then cosine of x. So what you want to do is you want to simplify everything in terms of x, sine of x, cosine of x. So now that I have this, if you notice, they both have a cosine. I'm gonna use my algebra. I'm going to factor out a cosine, and let's see, cosine of x. What else can I factor out? I can factor out a 2, okay? 2 cosine of x. And then what does that leave me with? Well, that leaves me with a 2 plus, and what is this one? That would give me sine of x equals to 0. Okay, so you notice what I did here? So this becomes my double angle. They both have cosine. Take out a cosine. I can take out a 2. All right, so now I have this. This guy's factored. This guy's factored. So now I have 2 times cosine of x equals to 0. And I have sine of x plus 2 is equal to 0. Cool. Now what do? I just solve it. So now this guy divide both sides by 2. Cosine of x is equal to 0. And where is cosine 0? Okay, well, where's cosine? Well, you're gonna have to look at your angles and the corners. Okay, guys, at the corner. All right, 0, 1 and 0, -1. Remember, cosine is the first number. Okay, so where is cosine 0? It's at pi over 2 and at 3 pi over 2. All right. What about this guy? All right, we solve it too. So we got sine of x is equal to -2. Now we got to figure out where is sine equal to -2. This is a bit of a trick question because the answer is it's undefined. There's no solution. Why is that? Remember, sine, the amplitude of sine goes up to +1 and -1. It never reaches -2, so this is undefined right here. So these are your only answers right here, pi/2 and 3 pi/2. All right, guys. Let's do some practice with the double angle here. How do you do this one? Well, this one you have to simplify it into one of the double angle formulas. And if you notice, if I take out a 3, you're left with 2 times sine of x cosine of x. And what does this become? That's your double angle formula. So that becomes 3, and it becomes sine of 2x. So what's your simplified version of this? Well, this becomes 3 times sine of 2x. There it is. Let's do the same thing over here. What does that become? Well, take out a 2, and you're left with 2 sine of x times cosine of x. And you notice I recognize this. That's the double angle formula for sine. So that becomes 2 times sine of 2x. Okay, because this becomes sine of 2x. Okay, now what about the letter C? It's a little bit more tricky, right? Well, how can I simplify that? Well, remember, you're going to take half of this angle here. All right, just take out the 5, and we'll just do this, and then 2, all right, and then sine of half of that angle is 2x, cosine of 2x. Whoops. All right, and what does this become? This becomes 10 of sine of 2x. And I actually should have, as soon as I took the half of it, I should have just gone to here. And what happened to the half that you took from here? Well, you multiplied it with a 5. All right, guys, so I took this, I recognize as my sine double angle formula. I took half of the 4 is 2, brought it out to the front, I multiplied it by 5, gives me a 10. As soon as I take the half of it, it goes to this right here, boom, 10 sine of 2x. All right, guys, and that's your simplified answer right there. All right, let's see if we can keep doing some more examples here. It says rewrite using the double angle formula. And if you notice, this is what I started with, 8 cosine squared of x minus 4. What do? It tells me to rewrite. So I factor out a 4, and I'm left with 2 cosine squared of x minus 1. Now, I know we're still learning these, but hopefully you can remember 2 cosine squared x minus 1. That's your double angle formula for cosine. Okay, so that's going to become cosine of 2x. And that's it. Now, if you needed to solve it, you can go ahead and solve it, right? Set it equal to 0 or whatnot and solve it. All right, so it's just memorizing the formulas and understanding what goes on between that, guys. Let's see if we can do another one here with tangent. Tangent, sometimes it gets kind of tricky, but all right, double angle formula for tangent. What do? Well, we know that it becomes 2 times tangent of x over 1 minus tangent squared of x plus tangent of x over here is equal to 0. Well, we got a problem, right? We have a fraction. Well, we got to solve this guy. What I'm going to do is I'm going to try to get rid of this denominator. So I'm going to multiply everything by 1 minus tangent squared of x. And that's what I'm going to do. I'm going to distribute everything, okay? And what happens when I distribute this guy over here? These guys are going to cancel out. We're just going to be left with 2 times tangent of x. Plus, we're going to distribute this. So 1 times tangent is tangent of x. And then minus. And then tangent squared times tangent. That's going to give me tangent cubed of x equals 0. So all I did, guys, is I distribute this guy. This times this times this. Okay. If that gets confusing, you can think about it this way. Like that. Okay. Tangent of x minus tangent cubed of x. Now I can go ahead and simplify stuff. This is going to give me 3 tangent of x minus tangent cubed. And now I use my algebra. I'm going to go ahead and factor out tangent. So I have tangent of x on the outside. That leaves me with 3 minus tangent squared of x. That equals to 0. What do you do now? Now that it's factored, I can set this guy by itself. So tangent of x is equal to 0. And the other one is 3 minus tangent squared of x equals to 0. Well, for this one, that's already done. Where is tangent 0? Where is tangent 0? And if you remember, tangent is dividing sine over cosine. I guess I'll go ahead and do it. Okay, so this is 1 comma 0, and this is negative 1 comma 0. Remember, it's sine over cosine, so 0 divided by 1 is 0. 0 divided by negative 1 is 0. So that happens at 0, and then at pi, and you can put 2 pi as well. Okay, guys? So that one's done. What about this guy? Well, if we solve this, we're going to have tangent squared of x is equal to 3. Okay, bring this guy to this side. Now we're going to take the square root. We're going to have tangent of x is equal to plus or minus the square root of 3. Now we got to figure out where, and we'll take this guy over here. Where is tangent square root of 3? Remember, tangent is sine over cosine. So we're going to take our hand. We want 3 fingers, sine over cosine, right? So we're going to fold this guy because this is the sine over the cosine. Square root of 3 over 1. Square root of 3 over square root of 1. So what angle am I folding? 60 degrees, which is pi over 3. But I want the positive and the negative. So pi over 3 is positive. Essentially, I want all of the 4 angles. So pi over 3, 2 pi over 3, and then it's 4 pi over 3, and 5 pi over 3. Okay, guys. And that's it. But you notice how I had to use my double angle, got rid of the fraction, distribute it, use my algebra to factor, and then I use my hand trig method in order to solve the rest. Okay, guys. How about number 5, the last one here? It says, let sine of theta be negative 3 over 5 in between 3 pi over 2 and 2 pi. That's where the angle is located. It's located in the 3rd quadrant. And I started to draw it out here this way, but I thought, you know what, it's better if I draw it more precisely here. It's in the 3rd quadrant. So if you notice, opposite is negative, right, because it's going down, and then the hypotenuse is always positive. When you use the Pythagorean theorem, you end up with 4. And it makes sense it's positive 4 because you're going to the right. If you draw it like this, that's perfectly acceptable too. Just make sure you don't get confused. So now what do? Well, what's sine of 2 theta? Well, that's going to give you 2 times sine of theta times cosine of theta. And then just like we did before, we just figure it out. Substitute, what is sine of theta? Sine is negative 3/5. Did they already tell us? And what is cosine of theta? Cosine is adjacent over hypotenuse. Oh, that's 4/5. And that's going to give us negative 24 over 25. All right, guys. What about cosine of 2 theta? All right. We can go ahead and use any of the 3, but let's go ahead and use just a simple one. 2 cosine squared of theta minus 1. So we're going to go ahead and use cosine. What's cosine? Adjacent over hypotenuse, so it's 4/5. We're going to square that, take away 1. And that's going to give me 2 times 16 over 25 minus 1. And that's going to give you 32 over 25 minus the 1 becomes 25 over 25. And that gives you 7 over 25. Okay. Nice. Last one is we're using is tangent. Tangent, and I'm sorry, you're just going to have to memorize it. It's going to give you 2 times tangent of theta. Okay. And then we're going to go ahead and have 1 minus tangent squared of theta. So what is tangent? Is opposite over adjacent. What's opposite? Negative 3 over 4. Cool. All right. The bottom, 1 minus, same thing, 3 over 4 Now it's negative 3 over 4, and we're going to square it. Okay. Now on the top, we're going to get negative 6 over 4. On the bottom, we're going to get 1 minus 9/16. Keep going. Negative 6/4. I should have reduced it. Over 16/16 minus 9/16. And that's going to give me, well, let's see, negative 3/2 over 7/16. Okay. And I'll just continue down here. Negative 3/2 times the reciprocal of 7/16 is 16/7. Divide by 2, that becomes a 1. Divide by 2 becomes an 8. Negative 24 over 7. Okay, guys. So hopefully that makes sense, and it's just applying the formulas that we're extending from summation and the difference formulas into now these double angle formulas. All right, guys, till next time.